Hi everyone, in this video we'll take another set of functions in math module. Let's get started. The first one is reduce all function. This function computes logical AND of elements across dimensions of a tensor. Let's say we have a tensor with just one dimension, and this tensor has just two elements. The first one is true, while the second one is false. So the data type of this tensor is Boolean. If we apply reduce all function on this tensor, the result is a tensor as well, and this tensor has just one element in it, which is false. And as we know, if we apply logical AND function on a set of elements, and there is one or more elements have false value, so the results equal to false. And it returns true if and only if all elements equal to true. Reduce all function has a bunch of arguments. The first one is input tensor, which is a Boolean tensor to reduce, while the second one is axis. If axis equal to none, which is default value of axis argument, so reduce all function will reduce all dimensions. The range of axis argument must be between minus rank of input tensor to the rank of input tensor. And the third argument is keep dimensions arguments. If you set it to true, reduce all function returns reduced dimensions with length 1. The last argument, name, which is a name for the operation. As you can see here, we have a tensor x. The data type of this tensor is Boolean, and this tensor is two-dimensional tensor. The length of the first dimension is the number of rows, while the length of the second dimension is the number of columns in this tensor. Now let's apply reduce all function on this tensor. So let's type tf.math.reduce underscore all function, open parenthesis. Now let's put x. Now let's run this. And as you can see here, here is the output, which is a tensor with just one element, false. It's because the default value of axis argument is none. So reduce all function will reduce all dimensions. Now let's specify the dimension that we want to reduce. So let's type axis argument equal to, as we said before, x tensor has two dimensions. The first one is rows dimension and the second one is columns dimension. So let's put the first dimension in tensor x, which is 0. Now let's run this. And here's the result, which is a tensor with just one dimension. This tensor has just two elements. The first one is false, while the second one is false as well. As we said before, we will reduce rows dimension. So we will apply logical AND function between these rows. The first element in the first row, which is true, and logical AND with the first element in the second row, which is true as well, and the first element in the third row, which is false. So true and false. The result is false, as you can see here. While the second element in the first row, which is false, and the second element in the second row, which is true, and the second element in the third row, which is false. So false and true and false, the result equal to false. Let's change this element to true and run this. So true and true, so the result equal to true. And as we said before, logical AND returns true if and only if all elements equal to true. Now let's change axis and set it to 1. So here we will reduce columns dimension. Let's run this. And here's the result, which is one-dimensional tensor. This tensor has 3 elements in it. The first one is false, and the second one is true, and the third one is false. Let's see what's happening here. Here we will reduce columns dimension. So we will apply logical AND function between columns of a tensor X. So true and false, the result equal to false, while true and true, the result equal to true, true and false, the result equal to false. We can use keep dimensions argument to make reduced dimension length equal to 1. So let's type keep dimensions equal to true. And here's the result. The shape of the output tensor is 3 by 1. 1 is the length of columns dimension, which is the reduced dimension. Let's put x is equal to 0 and see the result. Here's the result. Here we reduced rows dimension, so the length of the rows dimension equal to 1 here, because keep dimensions equal to true. Let's go to reduce any function. This function computes logical OR of elements across dimensions of a tensor. Let's say we have this tensor, one-dimension tensor with just 2 elements. Here's the first one, which is a true, and the second one, which is false. When we apply logical OR on these 2 elements, the result equal to true. And as we know, logical OR returns false if and only if the values of all elements equal to false. And as you see here, the value of this element is true, so the result equal to true. There is a bunch of arguments in reduced any function. The first one is input tensor, which is a Boolean tensor to reduce, while the second one is axis, which is the dimensions to reduce. If you set it none, which is default value of axis, then reduce all function will reduce all dimensions. Axis argument must be arranged between minus rank of input tensor to rank of input tensor. The third argument is keep dimensions argument. If you set it true, then reduce any function will return reduced dimensions with length 1. The last argument name, which is the name for the operation. Now let's say we have tensor X with data type Boolean. Let's apply reduce any function on this tensor. So let's type tf.math.reduce underscore any, open parenthesis. Here we will type X tensor, which is the input tensor argument. Now let's run this. And here is the result. As we said before, the default value of axis argument is none, so reduce any function reduces all dimensions. And the result is just a tensor with 1 element, which is true. If we set keep dimensions to true, so the shape of the output tensor is 1 by 1. Which returns reduced dimensions with length 1. And because we reduced all dimensions, so the length of the first dimension is 1 and the length of the second dimension is 1 as well. Now let's set axis argument to 0. So here is the result. Here we will reduce rows dimension. So here is the output tensor with just 1 dimension. Here we will apply logical OR function between these rows of tensor X. So the first element in the first row, which is true, or the first element in the second row, which is true as well, or the first element in third row in tensor X, which is true. So true, or true, or true, all elements here is true, so the result is true. False, or true, or false, so the result is true. Because there is one element here is true. Let's set keep dimensions true and see what's the result. And here's the result. We reduced row's dimension, so the length of row's dimension equal to 1, while the length of the second dimension equal to 2. Now let's reduce columns dimension. So we will put 1 here and see what's the result. Here is the result tensor. One-dimensional tensor. The length of this dimension is 3, which is the number of rows of the original tensor X. Here we will apply logical OR function between columns of tensor X. So true or false, the result equal to true. True or true, the result equal to true. True or false, the result equal to true. As we said before, logical OR function returns false if and only if all elements equal to false. Let's change this element to false and see what will happen. Here is the result. False or false, the result equal to false. And if we want the length of reduced dimension equal to 1, so we will set keep dimensions equal to true. And here is the result. The length of the first dimension is 3, while the length of the second dimension or reduced dimension is 1. Now let's take reduce max function. This function computes maximum of elements across dimensions of a tensor. Let's say we have this one-dimensional tensor with 3 elements in it. Here's the first one, which is 1, and the second one 5, and the last one 3. When we apply reduce max function on this tensor, the result equal to 5, which is the maximum number in this one-dimensional tensor. Reduce max function has a bunch of arguments. The first one is input tensor argument, which is the tensor to reduce. This argument should have real numeric type. And the second argument, axis, which is the dimensions to reduce. If you set it none, which is the default value of axis argument, so reduce max function reduces all dimensions. And this argument must be in range between minus rank of input tensor to rank of input tensor. The third argument, which is keep dimensions argument, if you set it true, then reduce max function will return reduced dimensions with length 1. The last argument, name, which is the name for the operation. Let's say we have this tensor X, which has 3 rows and 2 columns, and the data type of this tensor is integer 32. And we want to apply reduce max function on this tensor. So let's type tf.math.reduce underscore max function, open parenthesis, and here we will put X tensor. Let's see the result. And here's the result, which is a tensor with just one element, which is 9. And as you can see here, there are no dimensions because we reduced all dimensions. And the output 9, it is the maximum number in tensor X. Now let's reduce the first dimension or row's dimension. So let's type axis equal to 0. Let's run this. And here's the result. A tensor with just one dimension and this tensor has two elements, 7 and 9. Let's see what's happening here. Here we will apply reduce max function between rows of tensor x. So the first element in the first row is 1, and the first element in the second row is 4, while the first element in third row is 7. So the maximum number here is 7, and here is 7. Now the second element in the first row is a 3, while the second element in the second row is 2, and the second element in the third row is 9. So the maximum number here is 9, as you can see here. If we want to make the length of reduced dimension equal to 1, so let's set keep dimensions equal to true. And here is the result. The length of the first dimension is 1. It is the reduced dimension, while the length of the second dimension is 2, which is the number of columns. Now let's set axis argument to 1, which is columns dimension, so we will reduce column dimension here. Let's run this. And here's the result. It is one-dimensional tensor with 3 elements. Here's the first one, 3, and the second one, 4, and the last one, 9. Let's see what's happening here. Here we will apply reduce max function between columns of tensor x. So 3 greater than 1, and we will put 3 here. 4 greater than 2, so we will put 4 here. 9 greater than 7, so we will put 9. And if we want to make the length of reduced dimension equal to 1, so we will set keep dimensions to true. Let's say we have tensor x with just one dimension, and this tensor has just 3 elements in it. The first one is infinity, while the second one is 1, and the third one is 2. And if we apply reduce max function on tensor x, so we will reduce this dimension. So let's compare between the elements of this dimension. Infinity greater than 1 and 2. So the result is infinity. While if the value of this element is none, let's run this and see what's the result. The result equal to none. So if the value of any elements in a tensor equal to none, so reduce max function will return this value. While if we have minus infinity, let's see what's the result. As you can see here, minus infinity is smaller than 1 and 2, while the maximum number in this dimension is 2, so the result equal to 2. The last function that we will take is reduce min function. This function computes the minimum of elements across dimensions of a tensor. Let's say we have a tensor, one-dimensional tensor, with just 3 elements in it. The first one, which is the value of it 1, while the second one 5, the third one, the value of it 3. When we apply reduce min function on this tensor, the result equal to 1, which is the minimum value in this tensor. This function has a set of arguments. The first one is input tensor, which is the tensor to reduce, and this argument should have real numeric type. The second argument axis, which is the dimensions to reduce, if none, which is the default value of axis argument, so reduce min function will reduce all dimensions. An axis argument must be in range minus rank of input tensor to rank of input tensor. The third argument is keep dimensions. If true, returns reduced dimensions with length 1. The last argument, name, which is the name for the operation. Let's say we have one-dimensional tensor x. And this tensor has just 3 elements in it: minus infinity, 1, 2. And the data type of this tensor is float 32. So let's apply reduce minimum function on tensor x. tf.math module dot reduce underscore minimum open parenthesis x. So here we set input tensor argument. Let's see the result. And here's the result, which is minus infinity. As you can see here, minus infinity smaller than 1 and 2, or it is the minimum number in tensor x. So the result is minus infinity. If we change the value of this element to none, so the result equal to none. So let's now change the value of this element to infinity and see what's the result. And here is the result, 1. As you can see here, infinity is greater than 1 and 2. And 2 greater than 1. So the smallest number in this dimension is 1. So the result is 1. Thanks for watching.